Velocity is speed in a given direction. Constant velocity has the same speed and direction. It never changes direction. Always travels in a straight line. Nitro is pulled up the hill at a constant velocity by the speed doesn't change as you travel to the top. At the peak, things start to change. As the roller coaster travels down the hill, it begins to accelerate. But what is acceleration? Acceleration is any change in velocity. The equation for acceleration is a equals change in v over t. This means a equals final velocity minus initial velocity over the time. Let's do an example. Say you're driving a car at an initial velocity of 5 miles per hour and then accelerate to a speed of 10 miles per hour in a time of 2 seconds. Let's plug it in to find the acceleration. You need to find the quantity of 10 minus 5 divided by 2. The answer is 2.5 meters per second. Acceleration can be forwards or backwards. Backwards acceleration is called deceleration. Let's learn about Newton's laws as they apply to roller coasters. Roller coasters stay the same, which means they won't change velocity unless an outside force acts upon them or makes them change. On roller coasters, you experience g-forces. You can calculate these g-forces by multiplying the mass of the entire system by 9.8, the gravitational force. This is F equals ma. Let's try an example. Multiply 10, the gravitational force, by 100, the mass of the cart, to get 1,000 newtons. The seats push back on the riders, creating an equal and opposite reaction as the riders push back on the seat. This happens especially on the curves. Let's talk about some other concepts besides those that apply to roller coasters. Heat. Heat is a transfer of energy from hot to cold. Eventually, the two objects will reach the same temperature, which is known as thermal equilibrium. But what is the difference between heat and temperature? By the book, temperature is a measure of the average kinetic energy, which means how much the molecules move inside of an object. The more they move, the hotter the substance will be. It is important to remember that objects do not contain heat. They contain internal energy, which can produce heat. The equation for heat is H equals mass times the specific heat capacity times the change in heat. Let's do an example. Let's say you have a 20-gram brick of gold that you want to heat to 180 degrees Celsius from an initial temperature of 20 degrees Celsius, and the substance has a specific heat capacity of 0.031. Multiply the mass of the subject, which is 200, times the specific heat capacity of 0.031 times the quantity of the change in temperature to get 992 calories as your answer. Some people think electricity is just about light bulbs, but there's really much more to it than that. There are four major components in electricity: resistance, current, voltage, and power. Resistance is measured in ohms, current is measured in amps, voltage is measured in volts, and power is measured in watts. And a current of 7.5. Let's plug it into the equation. So 16 times 7.5 gives the answer of 120 volts. The current flows through the resistor and the voltage flows across the resistor. In a series circuit, there is only one path for electricity to flow on. In a parallel circuit, there are multiple paths for electricity to flow across, and if one path is cut off, some of the circuit can continue working.